Hello everyone, this is Experiment 2, The Magnetic Field of a Bar Magnet by Kiana White. First, I'm going to go over the table of contents for today's meeting. There's the purpose, the fundamental principles, the results, and the discussion. So, for the purpose of this experiment was to explore the relationship between the magnetic field and different observation locations. We'll go over the procedure and later on in this video. The fundamental principles of this experiment were Biot-Savart's law, which is nu naught over 4 pi times 1 over r third times 3 ur times r hat. The squiggly r is r hat in this equation minus nu. And then some of the example equations used in this experiment was for B bar, which was k equals r to the power of n. And then for B dipole for on the axis was nu naught over 4 pi times 2 times nu over r cubed. And then also this is for on the axis, and then if r was far away, or if r was much further than s. And the results of the experiment. So for the procedure, one was to determine the direction of the magnetic north by laying the phone on a table and utilizing a magnometer app. Then you used a ruler for the east and west directions, and then use tape to determine the north and south directions, and then record this data at various distances. Included is a picture of like an example phone layout. Some of the observations during this experiment. So one was when the magnometer is far away from the magnet, it measures a near zero magnetic field in the x direction, and this was yes. As the magnometer moves closer to the magnet, the measured x component of the magnetic field decreases, and the answer was no. The position of the magnometer has no effect on the measured x component of the magnetic field. This was also no. And then as the magnometer moves closer to the magnet, the measured x component of the magnetic field increases. Yes. So to sum all of that up, as per the computational model, B net is 2.381 times 10 to the negative fifth, and below are the values of B. For the discussion, what if in the experiment you oriented your setup so as to compensate for magnetic north? What if you had done that and had instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? How do you think your results would have changed? So the results of the experiment would have been different due to Earth's magnetic field, which was different in this case. And then for the second discussion question, what if you had two identical magnets and you redid the experiment, but instead of using a single magnet, you used two identical stuck together in the end? Then the dipole moments would be different. It would be like using a stronger magnet in this experiment, but then repeating it over. The values would be similar. The results would just change because the dipole's moment would be different. Here I have included some example code, and I've also included the Excel spreadsheet along with the graph. As you can see, I used the equations from earlier, and I also did different observation locations. In the bottom, I also have the B perp axis and the on axis code. In this next slide, well, let me give you guys a second to kind of go over the code. Okay, and the next slide, I have the perp printed, and I have the observation location at the 45-degree angle, and then this last code is the printout of all of that code that was followed. And then we can see here that all of the results of the experiment are stated below. In conclusion, all the results of the experiment were obtained, and again, B net was determined to be 2.381 times 10 to the negative 5. Thank you so much for listening.